UVC actually have the negative effect with the people or the skin and eye. Our innovation, we use the handheld type and make the cover for focus for screening.
So it's safe to use in public spaces even when there's people walking around?
Yeah, sure.
I'm Michael New, your host. Welcome to Thailand Today. As Thailand tackles a surge of new cases in this third wave of COVID-19 infections in the country, technological innovations are being developed to help the country fight against the coronavirus. Among them is Mahidol University's collaboration with AIS for the development of a mobile UVC sterilization robotic system, the UVC Moving CoBot. To find out more, today we speak to Dr. เอกชัย วารินศิริรักษ์ Head of Industrial Engineering Division, Faculty of Engineering, Mahidol University. Sawasdee krab. Thank you very much for coming on the program. Let's talk robots. First of all, what is the UVC Moving CoBot?
So, สวัสดีครับคุณไมเคิล UVC Moving CoBot is our innovation which produced under the COVID-19 pandemic from the last year, and so it's produced in the objective for killing the virus spread around everywhere in the public area. So we think this product or innovation can help the people for reduce some stress or reduce some worry of the people when they're living in the public area. So this is a UVC Moving CoBot.
So walk me through it exactly. If the CoBot goes into a hospital, what exactly will it be doing?
This CoBot can use in the hospital and also the public area.
Okay.
And also in airport, right? We hold the UVC lamp by the CoBot, and we run in the routing facility by the AGV, smart AGV, and then we can scan the UVC lamp on the target surface, which we need to kill the some virus, something. Yeah.
Now I remember I had another engineer from your faculty on. I believe it was Dr. Chakrit.
Yes.
Right. And he was also talking about a UV robot. Is this the same kind of robot, or are there differences between these projects?
A little bit different. Let's understand, like Dr. Chakrit, he's very expertise in the robot developer. So his robots is very good. But I actually am the how to say younger brother from of him.
Okay.
So I get some idea from him. Like he suggests us let's make some innovation with focus for kill the virus. And actually, if you see in the our CoBot, you meet two arms moving. That is his robot.
Oh, it's his robot. Okay.
I loan him. I loan him.
Oh, you're borrowing it.
Yeah.
So you have an existing robot that can do a lot of motor functions.
Yes.
And what you've done is you've written new software and added new attachments so that it can do this function specifically.
Yes, and actually I am like production engineering, and I just select the device has the good technology readiness, and I select one for integrate to get the new product for help some people or something like that. This is my way. But in my dean, Dr. Chakrit, he's designed and developed in the originality the robot for serve the deep function something.
So when your CoBot goes into a public space or the airport or the hospital, and it goes into a room and it wants to disinfect the room with UV. What's happening on the software side? Do you map out that room first, and so it only hits everywhere once, or does it work more like, do you know those robot vacuum cleaners, the Roomba, where it rolls along, it bumps into a wall, and then it turns, and it just keeps going?
I select the HEV which have like a good device like a LiDAR, and this HEV we already passed the EN safety standard. So that HEV can see first the mapping in the top view side because we select the HEV type of like a GPS mapping for see the routing. And it's be able for access by IoT when you need to change or reprogram. It means it's reprogrammable always real time. And when for real on-site apply, when we program the routing, it can go and when they found some obstacle, they can think this is should stop and change the routing automatically.
And make sure to get everything from both sides so that you're not missing anything.
Yes. And when the people walk, it will stop and think what it should be change the direction.
And not blast them with UV light.
Yes.
Right.
That's why we promote this innovation for play during people walk or people working, and no exposure of UVC out.
How long does it take to work on the software for a project like this?
So a little bit shy for say like this. Because I think really short time for first appearance of our innovation. Just allow 4 weeks. We succeed the first prototype and play in real field. And because I select the technology with already readiness. And integrate it.
Right. If you had to build a robot from scratch, it could have been many months.
It's no time in the COVID-19 pandemic. If we need to apply in the real application, you need to select in the device or some machine which you already have and adapt it.
Right. It's more efficient.
Yes.
What makes UV such an effective disinfectant?
Sure. UVC is the method of one disinfection method, right? Compared with the chemical, it have the consumable cost, and it's no thermal effect on the surface or material which you.
Oh, so it doesn't leave any heat.
Yes,
either.
No heat. That is advantage of the UVC.
How powerful is this UVC light that it's using?
Radiation, right? It can access to the DNA scale, and it can
and it'll break it apart.
The bonding in the DNA scale, right? It's really powerful because from the lab test, we already test in the vaccine development center under the molecular bioscience Mahidol University. We found that in the worst case of the parameter, we can inactivate or deactivate the virus at least 99.9%. Or log3.
Just by killing off its DNA.
Yes. In case of the far of UVC lamp and highest speed, we can kill it.
I imagine for the exact same reason, it's probably too dangerous for a person to do, which is why you have a robot.
So actually by our equipment, we design for focus only the surface. It's not exposed on
so it doesn't come out bad.
But why we select the CoBot for hold the UVC and go around? Because you can program it for play 24 hours. Just go back for charging. And if you have multi-HV, you can manage it for the schedule 24 hours for land in like a department store or in the Suvarnabhumi airport.
And I imagine it's very useful in areas that may have been infected with COVID, and you don't want to get people in there, put on PPE, and expose them to additional virus.
Can reduce significantly because you know per day for cost of PPE per one person at least allow two. Because when you take off,
right? Because you have to replace it.
You difficult for reuse PPE, right? And one PPE may be at least 500 baht per one set.
So quite expensive,
right?
For sure.
And we can reduce number of the labor for scan UVC, right? And also 24 hours you can manage the routing schedule or running schedule.
That's fantastic, and obviously this is why it's important to have robots in this field. Let's take a quick break, but we'll be back with more of Thailand Today, so don't go away.
Thai people have made it through the COVID-19 crisis because we all stayed home for the greater good to stop the spread. However, the global economy is on the decline. Thailand is no different. All sectors need to work together to accelerate our recovery. The government sector will reduce taxes, lower interest rates, and promote the business sector. As for the people, we will have to adapt to the new normal. This means working from home, studying online, finding new means of income, and staying safe. It's only if we can all stay healthy that we'll have the power to move the nation and balance our economy once again.
Welcome back. You're watching Thailand Today. We continue our discussion with Dr. เอกชัย วารินศิริรักษ์ Head of Industrial Engineering Division, the Faculty of Engineering, Mahidol University, on the UVC Moving CoBot, a mobile UVC sterilizing robot. When we left off, we were talking about how effective robots are in these day-to-day tasks that you can program, especially in an area that could be dangerous where someone might need PPE. Do you think there's other applications that we could use this robot?
Yes. In case of the dangerous area or some public area is also large and many people walk around there. So by our assumption, if we apply this robot, it can instead many people who have some risks, right? That been the concept of our innovation. Why we decide like that.
What role do you think this innovation will play in this current third wave of COVID?
So as I mentioned, UVC CoBot is safer than by our concept. Our type of the UVC exposure, we design the copper and focus radiation on the surface, right? We have another type is like open, but if you see UVC actually have the negative effect with the people or the skin and eye. So
this would be something that you could let go into a hospital that was empty.
Yeah.
You could go in and just shine it everywhere at once.
Yes, but our innovation, we use the handheld type and make the cover for focus for screening.
So it's safe to use in public spaces even when there's people walking around?
Yeah, sure. It's no exposure to the people. That is the big advantage of us. And why we focus in the use the type of handheld like this, because you can zoom in or make the high intensity of the UVC energy to the target surface and easily for kill the virus.
is this the only robot you're working on at the moment, or are you working on some other projects as well?
Actually, I am not a robot developer. I just integrated system engineer. And actually, my expertise is welding engineer for material side. But in our university, we have the big statement: we are wisdom of the land. That means when the people have the problem or our country have the problem, we should to focus on health, concentrate health, or support the people or doctor for past this situation. So, but in actually my work and I like in the material side and welding and joining side. So normally I help in the industrial side, but for this time I must help our country. So that means we apply. Actually, we use the robot for like welding in the automotive industry and things like that. But right now we need our robot for help the people.
Yeah.
Then
so you can actually use that same welding robot, but for medical purposes, because that's what Thailand needs right now.
Oh yeah. And you can help people for like no need the labor or go to the dangerous or serious area, right? And then you can reduce number of risks of the labor. Yeah.
What are some projects that you hope to work on in the future?
So because technology right now is very good, right? For robot, you normally you must to teach one by one robot. But right now you can use VR technology. And when you simulate and you teach in the program, you can transfer your command from the program access to the robot, multi-robot. That means you can reduce the lead time for manufacturing and also service robot. You can, when you use the VR technology, you can planning before real service robot go on site. And I think in the future soon, we will show like the concept for real-time robot operation like a human movement in real time, one by one.
How far away do you think we're from that?
So I think not more than 6 months.
Not more than 6 months, wow.
We will show the robot movement real time by EMG signals, something like that. And also we focus for use the robot help or assist like a vaccine development. In case of you need to test neutralization effect of the vaccine candidate, right? You can use the robot for play 24 hours for experiment for find which vaccine is a good matching with the people or is work or not. The solution no need for vaccine guy make the work 24 hours something.
Right, yeah. So it'll be able to do far more work than any one person. It can work 24 hours a day.
Yes.
And it can use AI to crunch those numbers incredibly fast.
So for AI, if you ever watch in the movie, when you check like the results of the testing, you will check like a plaque number, right? It's so try because it's too small and you must to check and count. Right now in our faculty, engineering faculty in Mahidol University, we use AI immunizer for snap one shot, 1 second and read how much is work in the vaccine source, in the human DNA, so something, so fast.
Say 10 years from now, where do you think we can see this robot developing towards? Like, where do you think this technology can lead you to?
When engineer success for products producing, we will call technology readiness level. But one big thing, we will ask about social readiness level. Social or people know or how to say have awareness of this product can it must be used or is not yet can use. We must to show the performance of our innovation. It will pass social readiness level or not. This is a big thing for us.
Doctor, thank you so much for coming on the program. I really appreciate all the work that you and your team do over at Mahidol University, and I know projects like CoBot are going to help us get through this last COVID cycle, hopefully. And I really look forward to see what new projects you have in the future. Thank you so much.
ขอบคุณครับ
ขอบคุณครับ Unfortunately, we have run out of time, but thank you so much once again to Dr. เอกชัย วารินศิริรักษ์ Head of Industrial Engineering Division, the Faculty of Engineering, Mahidol University, for sharing insights into technological developments such as the UVC Moving CoBot to help Thailand tackle this third wave of COVID-19. That's it for today's episode. We broadcast every Tuesday to Friday at 9 p.m. on NBT World and live on YouTube. I'm Michael New. สวัสดีครับ